All right, so I took your comment to mean, and don't correct me yet, that when you have multiple bandit arms, you want to choose the one that has the highest confidence.
Uh, that's not what I said, but okay.
I said don't correct me yet. So here we have two bandit arms, A and B, and we've pulled B twice, and we've seen one payout. And we pulled A once, and we didn't see it pay out. So in terms of expected value, B is winning.
Yes, B is winning.
And in terms of confidence, B is winning.
Right.
So what do you think the best thing to do is? Do you think at this point we should just always pick A, always pick B, or maybe something else?
I'm going to go with something else.
All right. So if we didn't have that third option, though, which would you choose?
That depends. How many more times do I get to do this? Well, wait, I'm forced to always choose A or always choose B?
Yes.
I guess I'd always choose B.
Yeah. That actually is not a bad idea. But the fact of the matter is that it's the always is problematic. And the reason you want to do something else is because, well, let me first tell you this because I bothered to compute it, so I might as well share it with you. I did the following calculation. I said if we were to randomly choose the payoff rates for both A and B, and then we pull A once and we pull B twice, if we happen to see no payoffs for A, one payoff for B, how often is the case that B is the better arm than A?
Okay.
And you were right that from the data that we have at the moment, B is a pretty good guess, and in fact, 70% of the time, B is the better of the two arms. But a full 30% of the time, A is the right arm. So you don't want to just go with B because you're going to be wrong almost a third of the time. A better thing to do is something else. So what's an idea for something else? What's a reasonable thing to do if we've got an arbitrary number of pulls left?
So if we have an arbitrary number, then we might as well talk about what happens after an infinite amount of time. If I had an infinite amount of time, then I know my true expected values for A and B, and so I know which one to pull, right? So another way of saying that is I want to do the thing that gets me more confidence in my expectations.